We will deal with the following objectives in this lesson. Understanding the operating principle of the decoder injection system link. During the Level 1 Immobiliser lesson, we saw that an Immobiliser system is always made up of the following components: the transmitter, the receiver, the decoder, and the injection system. The operation of the transmitter, receiver, and a section of the decoder were dealt with in the Immobiliser Level 1 lesson. This lesson will move on to the second section of the decoder and its link to the injection system. Let us look back at the way a first-generation Immobiliser system works. In first-generation systems, the Immobiliser system is linked to the remote control. The transmitter contains a code and the decoder carries the same code in its memory. After the code received by the decoder is validated, the doors and boot are unlocked. At the same time, the decoder calculates an authorization code to transmit to the injection system. Once the doors and boot are unlocked and the ignition is switched on, the decoder transmits the code to the injection system. The injection system analyzes this code. After validation, the injection system authorizes the engine to start. The doors and boot must be locked using the remote control to reactivate the Immobiliser system. The doors and boot are locked when the code received by the decoder has been validated. At the same time, the decoder enters active Immobiliser mode. The authorization code is important in communication between the decoder and injection system. As we have seen previously, the decoder transmits the authorization code to the injection system when the ignition is switched on. The injection system is a coded electronic unit that also contains a stored code. The authorization code received by the injection system is analyzed and compared to a stored reference code. If the authorization code corresponds to the stored code, the injection system is unlocked and authorizes the engine to start. If the authorization code does not correspond to the stored code, the injection system does not lock. In this case, the injection system does not authorize the engine to start and causes the injection warning light to flash. Now we shall look at the operation of the decoder and injection system. The decoder is a coded electronic unit that analyzes the electrical signal from the receiver and transmits an authorization or prevention signal for starting the engine to the injection system. When the code transmitted by the key is correct, the decoder unlocks the doors and boot. At the same time, the decoder calculates an authorization code to transmit to the injection system. When the ignition is switched on, the authorization code calculated by the decoder is transmitted as an electrical signal to the injection system. This electrical authorization signal is called a coded frame. The injection system receives the coded frame. The coded frame is analyzed and compared to the code stored in the memory of the injection system. If the injection system recognizes the code, it unlocks and authorizes the engine to start. We shall now see what happens when there is a transmitter fault. If the decoder has not received a code or has received the wrong code, it remains in active Immobiliser mode and does not calculate an authorization code to transmit to the injection system. In this case, when the ignition is switched on, no authorization code is transmitted to the injection system. When the injection system does not receive a coded frame electrical signal, it remains locked and does not authorize the engine to start. The injection warning light flashes. We have installed a non-coded injection system as a spare part. If the immobilizer is active, no code is transmitted by the decoder to the injection system. Since the injection system memory is blank, the injection system computer is not expecting a code to unlock it, and so it is possible to start the engine. In this section, we have looked at the following points. There are 4 basic components of an immobilizer system. If the immobilizer is inactive, an authorization signal called a coded frame is transmitted to the injection system. If the immobilizer is active, no signal is transmitted to the injection code. If the coded frame corresponds to the code stored in the memory of the injection system, the engine is authorized to start. If no signal is received by the coded injection system, it's impossible to start the engine. We have seen in the Level 1 Immobiliser lesson that the second generation is distinguished by the presence of an immobilizer warning light. The electronic key known as the transponder key in the transmitter-decoder connection also made its appearance in second-generation systems. We're going to look at the development of the injection system decoder connection for second-generation immobilizer systems. The key is recognized by the decoder. The immobilizer warning light goes out. If the decoder is in inactive immobilizer mode, the injection system decoder connection works in the same way as in the first generation. The key is not recognized by the system. The immobilizer warning light flashes rapidly. The decoder does not calculate an authorization code to transmit to the injection system. On the contrary, the decoder transmits a prevention code to the injection system. This prevention signal is called an absent frame. The absent frame is a development specific to second-generation immobilizer systems. The absent frame is a prevention code that is shared by and is identical in all immobilizer systems. The injection system interprets this prevention code as prohibiting the engine from starting. It is impossible to start the engine. The advantage of the absent frame is that it prevents the engine from starting even when the injection system is unprogrammed. When the immobilizer is active, even if the injection system is unprogrammed and thus not expecting an authorization code, it receives the absent frame that prevents the engine from starting. The absent frame needs to be prevented from reaching the unprogrammed injection system to be able to start. The recommended method during an injection system test is to take out the decoder supply fuse. When the decoder is no longer supplied, it can no longer generate an absent frame. In this configuration, the absence of an absent frame enables the engine to be started. However, the latest second-generation immobilizer systems require the injection system to be coded in order to work. It is therefore no longer possible to use an unprogrammed injection system to carry out tests, as once it has been coded, the code in the injection system cannot be erased. New injection systems must therefore be programmed according to the recommended procedure. In this section, we have looked at the following points. If the immobilizer system is inactive, it operates in the same way as the first generation. If the immobilizer system is active, the decoder transmits a starting prevention code known as an absent frame. The absent frame prevention code is shared and identical for all immobilizer systems, with the advantage of preventing the engine from starting even when the injection system is unprogrammed. The latest second-generation immobilizer systems require the injection system to be coded in order to work. The decoder function is supported by the UCH in third-generation Immobiliser systems. Moreover, transmitter-decoder communication is encrypted. When the ignition is switched on, the decoder identifies the serial number of the key. Then the decoder transmits a challenge to the key. If the response from the key corresponds to the result calculated by the decoder goes into inactive Immobiliser mode. The third generation is distinguished by a multiplex connection between the decoder and the injection system. The injection system is no longer passive in authorizing the engine to start. Indeed, the injection system requests starting authorization from the decoder when the ignition is switched on. The injection system transmits a challenge to the decoder. This challenge relates to the encrypted key being recognized. If the response from the decoder corresponds to the result calculated by the injection system unlocks and authorizes the engine to start. In this section, we have looked at the following points. The third-generation Immobiliser system is encrypted and the decoder function is supported by the UCH. The third generation is distinguished by a multiplex connection between the decoder and the injection system. The injection system transmits a challenge to the decoder.